Let us see the next question. The next question with which we are going to start is the Black-Scholes model. It is an option valuation model, and practically all over the world this is the only model which is used for option valuation. Binomial method, risk neutral method, which we have seen, have a biggest limitation that say they are making an estimation what would be the price of the security or price of the underlying asset on the date on which say the option is going to expire. No such assumption is made over here, and taking into account say the information which is actually available in the market, say the amount of the premium is calculated. So now in this question we are going to understand how to make the calculation of the premium amount using Black-Scholes method. You do not have to write anything. Let me first of all give an explanation to you that using this method how to make the calculation of the premium amount. So friends, over here let us have understanding that say how to compute the premium using the Black-Scholes model. And before that say I would like to introduce to you with the information that say they have provided. From the following data, compute the value of call option. The term value of the call option stands for call premium, and value of put option means put premium using Black-Scholes Option Pricing Model. Spot price of the equity share is 27. Strike price or exercise price is 25. Time period to expiration is 6 months, and the rate of interest is 6%. Stock return variance is 0.11. And of course we understand that the stock return variance is something which is new for us. So dear students, whenever you have been provided with the information about the standard deviation or variance, whenever you have been provided with this information, then in that case you are required to apply Black-Scholes model for the purpose of calculation of the premium amount. The term standard deviation, the term variance are the terms which are used in statistics, and that we are required to apply over here say for the purpose of premium calculation. Over here how the premium amount will be calculated, let us have a discussion of the same. We will make the computation of the premium amount something like this. Friends, over here we will make the computation of the answer in this way. Don't write anything. Step number 1 will be calculation of revised spot price of equity share. As far as this question is concerned, in this question, step number 1 is not applicable. Why it is not applicable? Because we understand that say we have not been provided with the dividend information. Step number 1 will be applied only if dividend information is given to us. Over here, we'll make the computation of the revised spot price as given spot price minus present value of dividend. In a way that say we understand that say whatever the spot price of the equity share is always inclusive of the dividend effect. So we'll compute the present value of the dividend to eliminate the effect of the dividend from the spot price of the security. That is the first step that we have. Step number 2 will be calculation of the discounting factor. let us have understanding that's how to make the calculation of the discounting factor. Everybody is requested to pay attention properly. Dear students, over here we are required to make the discounting factor calculation something like this. To explain that, I am giving you some small examples like this. Today and at the end of the year. Today, if at all we invest 1 rupee, then at the end of the year, what will be the maturity amount of deposit if rate of interest is 10%? The answer will be 1 rupee 10 paise. It is very simple to find like this. Now the same question. If at all 1 rupee is invested today at the rate of 10% and interest is semi-annually compounding, then in that case what would be the maturity amount of deposit? Then the answer is 1 plus 0.10 divided by 2 raised to 2. This is the way we compute the maturity amount of deposit, in a way that it is 1.05 raised to 2, and it would be 1.1025. That is the way the maturity amount of deposit would be calculated if at all the interest is semi-annually compounding. This is what we understand. Next, suppose the interest is quarterly compounding. In that case, what is the maturity amount of deposit? Let us understand it. It is 1 plus 0.10 divided by 4 raised to 4. That is the way the maturity amount of deposit is found. It is 1.025 into 234. So it will be 1.1038. That is the way the maturity amount of deposit can be calculated. So now we understand that, say, suppose instead of quarterly compounding, the interest is daily compounding. Then in that case we can say that over here it will be 365. That is the way we will have. That is the way we will have the calculation. So it is divided by 365 raised to 365. This is the way we will have the maturity amount of deposit to be calculated if at all the interest is on daily compounded basis. Now instead of daily compounding, suppose the compounding is made every hour. Okay, every hour. Then we can say that, say, into 24 and into 24. If at all the interest is compounding not hourly but every minute, then in that case over here into 60 and into 60. Suppose it is every second, then it is further into 60 into 60. It sounds to be very theoretical and it sounds to be really illogical when I am writing this. However, this is the concept. And the concept over here is that if at all the interest is having compounding even more than that, then in that case, what answer that we get is the answer which is given a technical name as continuous compounding and discounting. Continuous compounding / discounting. This is what we understand. Now friends, over here, why do we have some, that is a certain concept like this? The reason for that is that what happens that, say over here, Black-Scholes model has a kind of argument that the price of any security is not subject to the fluctuation after every second. Price of the security is subject to fluctuation on the constant basis. We know that practically, say at one point of time, there are number of traders, say, who give the quotation, who have the price say to be offered for purchasing slash selling of an underlying asset, for an asset, that is say for a security. So number of quotations at one point of time. That is the reason it is considered that we are required to make the computation of the compounding factor or the discounting factor which is required on continuously compounded basis. So in step number 2, we'll compute the discounting factor. Over here friends, for the purpose of calculation of the discounting factor, generally we understand that say we have a working like this, 1 divided by 1.03. How it is 1.03? We understand that so the 6% is the rate of interest for the entire year. So for 6 months it would be how much? It would be 3%. Exactly the same thing is applicable over here. However, over here the method of the presentation is slightly different, and at the same time, of course, the answer is going to be different. Because of the continuous compounding slash discounting factor, the compounded value would be more than what we have normally, and the discounted value would be less than what we have normally. So in step number 2, we will have the discounting factor to be calculated as e raised to negative RF into T. That is the way we make the computation of the factor. So it is e raised to 0.06 into 6 divided by 12. E raised to negative 0.03. This is the way we compute the discounting factor. Over here friends, so there is a E table which is provided on continuous compounded basis. There are basically 3 columns. Column number 1 is X, column number 2 is e raised to positive X, and column number 3 is e raised to negative X. So here basically, as I've explained it to you, it is e raised to negative RF into T, e raised to 0.06 into time period is 6 months, so it is 6 divided by 12. So e raised to negative 0.03. This is what we have. So here e raised to x. What is e raised to x? That is 0.03. Okay, it is 0.03. If at all the value is positive, then in that case it is that is compounded factor 1.0305, and if it is e raised to negative x, then it is discounting factor. This is the way we have the compounding factor and the discounting factor. Suppose the time period would have been 1 year, then in that case it is e raised to 0.06 into 1, that is e raised to negative 0.06. Then in that case over here 0.06, the compounding factor is this and discounting factor is this. And of course we are not interested in this, the compounding factor. We are always interested in the discounting factor. This is what we understand. So we understand that say we have done step number 1, in which we have made the calculation of the revised spot price. Now friends, in revised spot price, again you are required to make the computation using the continuous compounding slash discounting factor information. So what will happen over here, in step number 1, you are required to compute the revised spot price if required as given spot price minus dividend per share into e raised to negative RF into T. This is the way we are required to make the computation of the revised spot price. Now over here, when we are making the computation of the revised spot price, then the dividend per share will be discounted with the time period after which the dividend is going to be received by the investor. It means that, say over here, that is in this example we can see that the time period of the option is 6 months. Over here the time period of the option is 6 months. However, suppose the dividend is going to be paid after 3 months. Then in that case, when we are making the application of the discounting factor over here, then we have to consider 3 months and not 6 months. And when we are doing the final answer of the premium calculation, then in that case we are required to use 6 months. Step number 2 is the discounting factor. Now before I tell you the step number 3, I would like to tell you the kind of formula which we are going to apply for calculation of the premium. Value of the call means call premium is equal to spot price of the equity share into ND1 minus exercise price of the option into ND2 into e raised to negative RF into T. This is the simple formula which is required to be applied for premium calculation. S stands for spot price of the equity share, which is 27 rupees in this example. E stands for the exercise price of the option, which is provided to us as 25 rupees, into EF, that is e raised to negative RF into T, which say we already have understood. Let's say how to calculate the same. It is basically the discounting factor. So let us say it is 0.97045. We'll see that later on properly. Now there are two things that say we are required to compute. It is ND1 and it is ND2. ND1 and ND2 are basically the values which have been derived based on the normal probability distribution table. We have studied something like this in statistics, a concept called normal probability distribution. In that we have studied a bell-shaped curve diagram like this, wherein exactly the middle point is considered to be the x bar. This is considered to be the x bar. We understand that this is indicating the deviation, that is called standard deviation from the mean value. It is also called the dispersion from the mean value. This is what we have. Over here, we are required to calculate the value of ND1, normal probability distribution of D1 value, and ND2, that is again normal probability distribution of D2 value. As far as the D1 value is concerned, it is calculated by using a value like this: natural logarithm of S divided by E plus RF plus variance divided by 2 into time period divided by under root of time period into standard deviation. This is a formula which is required to be applied for calculation of D1. Whatever the value of the D1 that we compute, so that we are required to look into the Z table. Then we'll make the calculation of ND1. Afterwards we'll make the calculation of D2. There is similar formula that we have for D2 calculation. Then again that will be located in the Z table, and then we'll make the computation of ND2. Whatever the value of ND1 and ND2 that we compute, so that we will keep in this equation for the purpose of making calculation of the value of call, that is call premium. This is the process that we have. We already have reached to step number 2, in which we have understood that say we are required to find it, that is the discounting factor, that is e raised to negative rf into t. Now step number 3, in that say we'll make the calculation of ln s divided by e, that is natural logarithm s divided by e value. That is what say we are going to have. So the step number 3. Then step number 4 will be calculation of d1. Step number 5 will be nd1. Step number 6 will be d2. Step number 7 will be nd2. Step number 8 will be value of call, that is call premium. If at all the question speaks, that is if at all it is provided to us, in this question it has been provided to us to compute the value of the put. As far as the Black-Scholes model is concerned, the Black-Scholes model premium calculation is able to find only the call premium value. It is not self-sufficient to compute the put premium value. That is the reason, say we will apply over here put call parity theorem for the purpose of calculation of put premium. We know that so the put call parity theorem works like this. Value of put, that is put premium, plus spot price of the security is equal to present value of exercise price plus value of call. So now put premium will be found as balancing figure, in which present value of exercise price, that is exercise price into again e raised to negative rf into t. That is the way its discounted value is calculated, plus value of the call which we have found over here, minus spot price of the equity share which is 27. So over here it is 25. Then we have the discounting factor to be applied 0.97045 in this example, value of the call which we have calculated above, and then spot price of the equity share is deducted in order to make the computation of put premium. So this is the sequence in which we are required to make the calculation of answer. For D1 calculation, I have told you the formula. For D2 calculation also similar value is there. As far as the ND1 and ND2 is concerned, for calculation of the same, how to make the calculation, that I am giving explanation to you now. Suppose the D1 value is, suppose I am taking a value as 0.5466. I am taking just a random value. Suppose it is 0.5466. Then based on that, how to make calculation of ND1, that I am explaining to you. First of all, friends, we are required to see the Z table reading. So here, we are supposed to see 0.5466. So whatever the value that say we are required to find, we understand that say we are required to see 2 digits after the decimal. So here 0.54. Why only 2 digits? Because over here, so the Z table would be provided to us up to 2 digits. That is the reason. So 0.54. So 0.54. So it is 2054 and then 55. The next digit, that is 2088. These are the two values that say we will see. Okay. So 0.54 and 0.55. 0.54 the reading is 0.2054 and for 2088. Now we are required to have the reading of 0.5466. So what we have to do, we are required to do interpolation. 54 and 55 has a difference of 0.01 and 0.2054 and 2088 has a difference of 0.0034. Now we will do the interpolation like this. Generally, I suggest students to take the base of the lower one. So the reading is 0.2054 plus 0.0034 divided by 0.01 into 0.0066. See what I have done, 54 to 55. There is an increase by 0.01. That 0.01 is representing 0.0034. That is the value by which the reading increases. So when the reading increases from 0.54 to 0.5466, means there is an increase by 0.0066. It is represented by this much change in the reading. So that would be calculated as multiplication of this two, that is 0.0034 into 0.0066 divided by 0.01. So 0.0034 into 0.0066 divided by 0.01. So it comes to 0.0022 plus 0.2054. That is the way it is 0.2076. That is the way we will have the reading of D1 in Z table. So this is the way we are required to find the D1 reading from the Z table. Similarly, D2 reading will also be found in the Z table like this. How to compute D2? I just explained that to you in some time. Now, basically we are interested to know ND1. For the purpose of ND1 value, what you are required to do, friends? You have to see that whether D1 value is positive or negative. You have to see whether D1 value is positive or D1 value is negative. Because the same value may be negative. Friends, whether it is positive or negative, the Z table reading is always going to remain same. It is never going to alter. So now if it is positive, then in that case ND1 is equal to 0.50 plus Z table reading. And if it is negative, then in that case it is 0.50 minus Z table reading. This is the way ND1 is calculated. So over here 2076. So 0.50 plus 0.2076. So 0.7076. And if at all it would have been negative, then in that case 0.50 minus 0.2076. So 0.2924. This is what we understand. Now, as I told you that this is basically a bell-shaped card diagram representing, that is, normal probability distribution value. If at all the D1 value is positive, then in that case basically we are interested in this area. That is the reason, so whatever the D1 reading from the Z table is added to 0.5 for the purpose of calculation of ND1. And if at all, so the D1 value is negative, then in that case we are interested in less than 0.5 area. That is the reason, so whatever the reading that we have is subtracted from 0.5 for the purpose of making calculation of ND1. This is what we understand. Now friends, one of the important point which is yet to be explained is calculation of ln s divided by e. That is natural logarithm of spot divided by exercise value. Now for the purpose of calculation of natural logarithm s divided by e value, again, so there are two methods by which you can make the calculation. I am explaining both the methods to you. In examination, you can apply either of the method. Friends, as far as the ln is concerned, that is the natural logarithm value for s divided by e value. Of course, so on our normal calculator, we cannot calculate it. There are two methods by which we can do it. The first method is slightly lengthy method. It is like this. In that step A, spot divided by exercise. Spot is 27, exercise is 25. So what will happen? 27 upon 25, it is 1.080. In a way that say S divided by E, spot divided by exercise will be calculated in total for 4 digits, 1.080. Then step B is 10 base log table. 10 base log table value may be provided to you in example. So 10 base log table starts from 10. You can see that the value in which we are interested upon is 10, 8 and 0. So over here we understand 10, 8 and mean difference 0 is always going to be 0. So over here the reading is 0334. This is the reading. So over here it is 0334. This is the 10 base log table reading. Step C is Barban procedure. In the Barban procedure, friends, what we are doing, we have to see that say before decimal how many digits are there in S divided by E. That is 1 digit before decimal, 1 digit. So 1 minus 1 is 0. So we mention over here 0.10 base log table reading. So over here 0.0334. This is the way we have to do Barban procedure. So it is 1 digit before decimal minus 1 is 0. And finally ln is divided by E. That is the step D, in which step number C into 2.303. 2.303 is a fixed value for conversion of 10 base log table into scientific log table value. So over here 0.0334 into 2.303. That comes to 0.07692. 0.0769202. This is what say a process by which you can compute ln S divided by E. At the same time, so there is a shortcut method. The shortcut method is like this. In that say, it is S divided by E once again. What is the value of S? It is 27. What is the value of E? It is 25. It is 1.080. Then you are required to do under root for 12 times. So 1.08. Please start doing it with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer which I am getting is 1.1234. 1878948. Afterwards we are required to deduct 1 from it. So deduct 1. So we'll have the value 0.1234. 4 times 0, 1878948. Whatever this value that we get into 4096. So minus 1 into 4096, that is a fixed value. And with that, say you can get the ln s divided by E. It is 0.0769617. So you can see that, say you are able to get answer which is very near to it. There is a difference of 0.00004. Okay, 1 2 3 4. Then over here it is 2 and over there it is 6. So of course that much difference is definitely acceptable. So this is the way, say we are required to make the computation of ln s divided by E. In examination, of course, you can process the answer with either of the method. However, there may be a possibility that, say, this 10 based log table may not be provided to you. That is the reason it is essential for you that, say, you understand that, say, how to make the calculation of answer with this method. You may every time do the answer with the first method, or you may do answer with this method. Both of them are acceptable and both of them are going to lead you to the same answer. So I have explained to you step number 3, how to make the calculation of ln s divided by E. Step number 4, in that, say, the D1 calculation. For that, say, simply we have to apply a formula like this. The rest of the values are provided to us in the example, like a risk-free rate of return, variance is given, divided by 2 is a value only, T is the time period, that is 0.5, under root of the time period into standard deviation. D2 again, for that, so there is a small formula. I'll explain you while processing the answer. And D2, again you are required to read the D2 value from the Z table. If at all the D2 value is positive, then add that reading to 0.5 to compute ND2. And if it is negative, deduct the same from 0.5 to compute ND2. Value of the call, for that, say, this simple formula will be applied. Yeah, this is a formula which is required to be applied for call premium, and lastly we'll make the calculation of put premium. So the heading write down. Black-Scholes model B&S model for premium calculation. In that, write down first point. This method of premium calculation is only for call premium, comma, not for put premium. Full stop. To compute put premium, we have to apply put call parity theorem. Second point, over here we use concept of continuous compounding / discounting factor. footstep. Third, over here, for calculation of call premium, generally following steps are followed. Step number 1, calculation of revise the spot price of equity share, comma, if dividend information is given. Second, calculation of e raised to negative rf into t. Third, calculation of ln s divided by e. Fourth, d1. Fifth, nd1. Sixth, d2. Seventh, nd2. Eighth, vc, value of call. Fourth point, e raised to negative rf into t is indicating discounting factor or present value factor. Fifth, T will be calculated as under time period and value of T. Time period is 12 months, then value of T would be 1. 9 months, then it is 0.75, that is 9 divided by 12. 6 months, it is 0.5. 3 months, 0.25. 100 days, then 100 divided by 365. Okay, this is the way the value of T will be calculated. Sixth point, D1 will be found using following formula. Ln S divided by E plus Rf plus variance divided by 2 whole into T divided by under root of time period into standard deviation. ln s divided by t is equal to natural logarithm for s divided by e value. RF stands for risk-free rate of return. T is time period of option. This is the sign of variance. And this is the sign of standard deviation. Next point. In case of calculating revise the spot price of equity share, comma, we have to use following formula. Revise the spot price is equal to given spot price minus dividend per share into e raised to negative RF into t. In above formula, t will be taken as time period after which dividend is going to be paid. Full stop. Eighth, ln s divided by e can be calculated with either of the following method. A, B, C and D. S divided by E up to 4 digits. Read 10 base log table. Bar 1 process. And lastly, ln s divided by E is equal to step C into 2.303. These are the 4 steps that we have. Or otherwise, you can do working alternatively like this. I am writing it over here. In that, S divided by E value under root for 12 times deduct 1 multiply above answer by 4096. These are the 4 steps. Next point, for ND1 calculation, comma, we have to read Z table for D1 value. Full stop. ND1, I'm sorry, D1 is greater than 0, ND1 is equal to 0.5 plus Z table reading. And if at all the D1 value is less than 0, then ND1 is equal to 0.5 minus Z table reading. With paragraph write down, N stands for normal probability distribution table. Normal probability distribution. Full stop. So we have to read Z table. Full stop. For ND2, same process will be followed, comma, in that D2 reading of Z table will be used for ND2 calculation. Full stop. D2 can be calculated as under. For D2 calculation, there are two formulas once again. ln S divided by E plus RF minus variance divided by 2 whole into T under root, that is divided by under root of time period into standard deviation. Or otherwise, we can do answer with another method, D1 minus under root of T into standard deviation. That is the way we have the another formula. These are the, that is either of the way you can compute the answer. Sure. Let us do now answer. Step number 1 is calculation of revised spot price. This step is not applicable over here. Why? Because we understand that there is no dividend information. Step number 2, in that, calculation of e raised to negative rf into t. That is the way the step number 2 is there. Step number 2 is e raised to negative rf into t. So it is e raised to negative rf. What is the risk-free rate of return? Risk-free rate of return is 6% and the time period is 6 months. So e raised to 0.06 into time period is 6 divided by 12. So e raised to negative 0.06 into 0.50. So in that case, e raised to negative 0.03. Now we'll see the e factor table. So in e factor table, it is e raised to 0.03 negative, so 0.97045. So it is 0.97045. That is the step number 2. Now step number 3. Calculation of ln S divided by E. That is the answer to be done. So we can do by either of the method. S divided by E, that is 27 upon 25. That comes to 1.080. Then we have to refer the 10 base log table. This is A, then B is 10 base log table. So 10, 8, in that it is 0, 3, 3, 4. Then the mean difference, for 0 the mean difference is 0, so we don't have to add anything. Step number C is bar 1 process. Bar 1 process is 1 digit before decimal, so 1 minus 1 is 0, so 0.0334. Next, step D, in that ln S divided by E is equal to 0.0334 into 2.303. This is what we are required to calculate. So 0.076920. This is the way ln S divided by E will be found. Or otherwise, what you can do, S divided by E, 27 upon 25. That is 1.080. Then under root of 1080 for 12 times. So 1.08, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is 1.4 times 0, 1878, 948. Then we'll deduct 1 from it. Deduct 1. So we'll have 0.1234, 1878, 948. Then the final answer is 0.4 times 0, 1878, 948 into 4096. Zero 0.0 0.769617. So either of the value that we can take for doing answer, I am going to carry forward this value for the purpose of calculation. Either of them will not make a huge difference. Step number 3. Calculation of ln s divided by e. Calculation of d1. It is ln s divided by e plus Rf plus variance divided by 2 whole into t divided by under root of t into standard deviation. This is the formula. This value I am carry forwarding. It is 0.0769617 plus Rf. What is the risk-free rate of return? 0.06 plus variance. What is variance? Variance is 0.11 divided by 2. Okay, variance is given to us in the question. Here is the variance given, it is 0.11 into time period. Time period is 0.5, 6 divided by 12, whole divided by under root of 0.5 into standard deviation. However, we have variance, no problem, we'll do under root of 0.11. So now what we will do, friends, first of all we'll do 0.11 divided by 2, that is 0.055. Then we will add 0.06 to it, so it is 0.115. Then we will multiply it with 0.5, so 0.0575. Whole divided by under root of 0.5 under root of 0.11. We'll do multiplication of both of them, and it is 0.2345. So 0.0769617 plus 0.0575 divided by 0.2345, so 0.5734. This is the way we'll make the calculation of D1 value. That an answer. Step number 4. Sorry, this is step number 4. And now step number 5. Calculation of ND1. Let us see for ND1 what we will do. D1 value and Z table reading. D1 value we will see 0.57 and 0.58. Okay, so 0.57 and 0.58. So 0.57 is 2157 and 58 is 2190. So 0.2157 and 0.2190. Difference of this is 0.01 and difference of this two is 0.0033. So the final answer would be like this: 0.2157 plus 0.0033 divided by 0.01 into over here 0.0034. So this will be added to the 0.2157 for the purpose of writing the final answer. So 0.0033 into 0.0034 upon 0.01. So 0.2157 plus 0.0011 so 0.2168. And this is a leading. Now we understand that say for the purpose of ND1 calculation, we have to see whether D1 is positive or negative. It is positive. So we understand that say the ND1 is equal to 0.50 plus 0.2168, that is 0.7168. This is the way ND1 will be found.